2024 HSC Extension 1 Prediction Paper Review. Let's get started straight away. First question. You got polynomial p of x, equation of which is given. Value of a such that x plus 2 is a factor of p of x. Now, if x plus 2 is a factor of p of x, according to the factor theorem, p of negative 2 will be equal to 0. In other words, negative 2 cubed plus 8 times negative 2 squared minus 5 times negative 2 plus 10 is equal to 0. And rearranging that gives a as negative 3 as your answer. Moving on to the second question. Mr. No's new business has got 12 karaoke rooms on average. Each of the rooms are in use 70% of the time. What is the probability that at a particular time exactly 8 out of 12 rooms are in use? Binomial probability. 12C8. For the number of combinations of 8 out of the 12 rooms that could be in use, it could be the first 8 rooms, it could be the last 8 rooms. 12C8 represents the number of different combinations of 8 out of the 12 rooms that could be in use at this particular time. 0.7 multiplied by, 0.7 raised to power of 8, because the probability that each room is in use is 70%, and here 8 of them are in use. In contrast, the other 4 rooms, the other 4 out of 12 rooms are then not in use, and the probability that a particular room is not in use is 1 minus 0.7 or 0.3. You raise that to the power of 4 because 4 out of the 12 rooms are not in use. Put that in the calculator. 0.2311 is your answer. Third one, simple differentiation. So again, derivative of inverse sine functions. 1 over square root of 1 minus, and then this thing that I've just underlined, squared. But of course, if this thing that I just circled is a function of x, we need to multiply by the derivative of that, okay, according to the chain rule. So here, derivative of 2x, we multiply by 2. And if you do the algebra, d is then your derivative. Question number 4. The function square root of f of absolute value of x is undefined for any real values of x. Which of the following could be the graph of f of x? In order for us to solve this question, for you guys to solve this question, you need a bit of understanding of the conditions for which that function will be undefined. The conditions for which square root of absolute value of x will be undefined. And the conditions which I'm talking about is this being negative, because essentially the function which we are required to think about is a square root function. And for square root functions, if the expression under the square root is a negative value, takes a negative value, well then the square root function will be undefined. So here, under the square root, we got f of absolute value of x, which if that's negative, the function, the square root function, the square root of that will become undefined. Okay? And what this then means is that the graph of y equals to f of x, which the question asks for over here, cannot be in the first quadrant. Because, so for instance, if you look at option C, you got this part of the graph right here. That's in the first quadrant. Now, if the graph of f of x exists in the first quadrant, then the graph of f of absolute value of x would exist in the first and the second quadrant, wouldn't it? Why? Because the graph of f of absolute value of x is obtained by reflecting the graph of f of x to the right of the y-axis, across the y-axis, essentially, as I have done with example C. You see this part of the graph? I reflected it across the y-axis and obtained this part, okay? And the highlight yellow graph, okay? The graph represented by the yellow line is the graph of f of absolute value of x, isn't it? But if that's the graph, if this is the graph of f of absolute value of x, well then f of absolute value of x is positive, which then means the square root of that, which the question talks about, the square root of that over there, that should be defined. But of course the question says otherwise. It says it's undefined, doesn't it? Right? So for the same reason, the other two options, A and D, which have graphs in the first quadrant, cannot be the answer. It cannot be the answer. The answer then must be B. Because if you consider B, the graph of f of absolute value of x would look like that, which, as you can see, for every value of x, that's a negative, the function value is negative, isn't it? So when you take the square root of it, for any value of x, when you take the square root of f of absolute value of x, your square root function will be undefined, making B the correct answer. Next, question 5. We got the graph of p of x shown. Which of the following is true about A, B, and C? This question can be answered using the relationship between roots and coefficients of a polynomial. So since we have a cubic polynomial, and from the graph, it is evident that the polynomial, cubic polynomial, has got 3 distinct real roots. Let those roots be alpha, beta, and gamma respectively to begin. And what we can see from the graph, and especially from where the roots are located, I've just circled where the roots are located, haven't I? Is that all 3 of the roots are negative values, aren't they? These are all less than 0. So then the sum of those roots must also be negative. And that means, according to the relationship between roots and coefficients, my negative b over a is negative. But we know that a is a negative leading coefficient. Again, that's from the shape of the cubic function that's given in the question, isn't it? we can see that as x approaches infinity, y over here decreases to negative infinity, which is an indication that a, the leading coefficient, is negative for this cubic. And in fact, if you look in the options A, B, and C, and D, every single one of the options say that a is negative. So knowing that a is negative in this inequality, well then b should also be a negative value, shouldn't it? Should also be a negative value. Now C, the sign of C can also be figured out in a similar manner. So for C, we can consider the sum of the roots taken two at a time, alpha beta plus gamma alpha. But again, since we know that alpha, beta, gamma are all negative, if you take two of them at a time and you multiply them, negative number multiplied by a negative number would give a positive number. So in other words, alpha, beta, beta, gamma, alpha are all positive numbers, such that the sum of them is also, of course, positive. Then according to the relationship between roots and coefficients, C over A is positive. But again, we know that A is a negative number. That's an indication that C must also be negative, isn't it? So based on all of that, the answer then must be D, isn't it? Okay, then. Now moving on to question number 6. So for this one, you just basically had to trace the particular solution which passes through the origin carefully. So, in your first quadrant, you just had to carefully trace the solution which passes through the origin by following the slopes that are shown in the slope field. And you can then figure out that 1, 1 is probably the best approximation of the horizontal point of inflection that your particular solution has, right? Stationary point. This could have been a maximum, it could have been a minimum, it could have been a horizontal point of inflection, but by carefully tracing the particular solution on your slope field, you can recognize that it's the horizontal point of inflection which occurs at the point 1, 1. Therefore, C. Moving on to question number 7. We got a function f of x defined by parametric equations. What is the gradient of tangent to the inverse function? Well, for the inverse function then, x and y would be swapped around, wouldn't it? So for inverse function, y equals to inverse f of x, I'm saying, x would be cosine t, y would be 2 sine t minus 1. X and y. Swap these x and y. Swapped around, isn't it? And your job is to find the gradient of the tangent to this function at the point where t is equal to pi on 4. Gradient of tangent. In other words, dy dx. Of course, dy dx would be dy dt multiplied by dt dx. You use chain rule like this in case where your function is defined parametrically. And dy dt, derivative of 2 sine t minus 1 to cosine t multiplied by dt dx. Dt dx is the reciprocal, so 1 over the derivative of x with respect to t. I'm saying dt dx is 1 over dx dt. And dx dt, derivative of x, derivative of cosine t is negative sign. Which of course simplifies down to negative 2 cot t, cosine over sine, being cot. And at the point where t is equal to pi on 4, substitute in pi on 4, cot pi on 4 is equal to 1. So therefore your dy dx, your derivative, is equal to minus 2b. Moving on to question 8. Normally for questions like this, I would, again, recommend you guys to substitute points which are shown on these options, on the graphs, into the equation and pick the one that satisfies all the points that it should satisfy. That's what I would normally recommend. Okay. However, that's not very effective for this question because the options show you the shapes of the graphs, but they don't specifically show the points that your graph passes through. So as in, for points like the x-intercepts like this, we know that the x-intercept is a horizontal point of inflection if A is the answer. But we don't know its coordinates, meaning we can't really substitute it in to the equation to verify whether A is the answer or not. Okay, so in this case, what I will do is I will actually just figure out from the equation of the trig function given, I will actually just figure out the shape of the graph, the shape of its graph using calculus. So that is y dash is equal to that. And I will put that equal to 0 and of course the logic behind putting a derivative equal to 0 is to find the stationary points, isn't it? So to solve the equation for x, double angle formula, rearrange, factorize, Oops, and I was supposed to have 2 here when I apply the double angle formula, aren't I? So yes, again, factorize. And then factorize again. There we go. Sine x is equal to 1, or sine x is equal to negative half. And in the domain of x given in the question, which is from 0 to 2 pi, 0 to 2 pi, the solutions to these equations are then pi on 2, 7 pi on 6, and 11 pi on 6. 3 stationary points altogether. The nature of which can be worked out either using the second derivative or using the table of values, isn't it? Okay, so as in you guys get what I'm doing. Construct a table of values for these particular values of x. And of course, guys, at the 3 solution values that we found, the derivative should, of course, all equal to 0. You substitute the other x values, the 0, the pi, the 3 pi on 2, and the 2 pi, respectively, into the derivative to figure out whether it is positive or negative. And when you do that, you end up with these values indicating your graph increases, stops, decreases, stops, and then increases, doesn't it? And that's the shape of your graph. And the option that's got that exact shape is A, isn't it? Therefore, making A the correct answer. Moving on to question number 9. Trajectory of a projectile fired from the origin. The position vector and the velocity vector are given by s and v respectively. At which point could s dot v be negative? Okay, the significance of dot product. Being negative, a dot product being negative, means that the angle between your 2 vectors S and V is obtuse. Of course, vice versa. If the dot product is positive, then that's an indication that the angle between the 2 vectors that you took the dot product of is acute. But here it's negative, so obtuse. And in case it's perpendicular, equal to dot product is equal to 0, isn't it? So then we just need to pick the point at which the displacement vector from the origin and the velocity vector at that point can have an obtuse angle between them. So for example, if you look at B, this, which I've just drawn, that should displacement vector S and your velocity vector at point B is directed horizontally to the right. And the angle between these two cannot be obtuse. Why? Because where's the angle between these two? The angle between these two vectors is over here, isn't it? That theta clearly is an acute angle. It cannot be obtuse. So then at which point? At what point can the angle between the displacement vector S and the velocity vector V be obtuse? And that's at point C, because at point C, this be your displacement vector, and then tangential to the trajectory, this would be your velocity vector. And you guys can see that that really is the only point at which this angle theta between the displacement vector and the velocity vector could be obtuse. Okay, if you perform similar analysis, if you perform similar kind of, draw similar vectors for the other points, all 4 points A, B, C, D, you will realize that for points A, B, and D, the angle between S and V has to be acute. It is only at point C, in other words, it is only when the projectile is, at C, that the angle between S and V could potentially be obtuse. Okay, so therefore, C is your answer. Next, last multi-question. So, applying the property which is given to us in the question. Okay, applying this property that's given to us in the question, you have to recognize that the pi on 2 should correspond to A in the given property, and that the integrand, right? The integrand, the sine x on sine x plus cosine x, you essentially treat that as your f of x. So according to the given property, you can write this as pi on 2, 0, and then f of a minus x, so f of pi on 2 minus x. Like this. And of course, sine pi on 2 minus x that you have on the numerator, and in fact you got one in the denominator as well. But yes, sine pi on 2 minus x is cosine x, and vice versa. Cosine pi on 2 minus x is equal to sine x, isn't it? So you can then write this as the following, can't you? And then if you have solved this question, or if you have had a look at the solution file, okay, you would have recognized that the solution file uses a pretty nice, clean algebraic trick to evaluate the integral now, okay? And that is to add this, to add that to both sides of the equation. And when you do that, of course, on the left-hand side, you have 2 times the same thing. But on the right-hand side, this plus this, because the boundaries are the same, you can then add the integrands, and when you do that, you get sine x plus cos x over sine x plus cos x. In other words, you end up with 1. And that integrated becomes x, take upper minus under, you end up with pi on 2. And then the answer is pi on 4. Why? You had the 2 over here, didn't you? So dividing both sides by 2 gives you what your original integral is equivalent to. And that's pi on 4. So yeah, that's the end of the multiple choice. Let's now move on to the short answer questions. Question 11. Solve the inequality. Right, multiplying both sides by x plus 3, all squared. Produces that. And rearranging this gives a quadratic inequality. This is greater than or equal to 0. Factorize out x plus 3. Simplify. You get that. And that's a, yes, quadratic inequality which you solve. Which you can solve graphically using the parabola x plus 3, parabola with the equation x plus 3, x plus 7. And the solution that you get is either less than or equal to negative 7 or strictly greater than minus 3, because we should have noted from the initial question that x equals to minus 3 is a restriction, isn't it? So when we write our answer does not include minus 3. Next one, 11. Coefficient of x to the power of 7. Right. We need the expansion. So this is the sum of 11 terms. That's got the general structure 10CR, 1 to the power of 10 minus R, and negative x on 2 to the power of R. Of course, there's no need to write 1 to the power of 10 minus R. That's always equal to 1. 1 raised to the power of anything, it's always equal to 1. Okay, and multiplication by 1, there's no need to write that. And splitting the coefficient out, I can write this as -12 to the power of r multiplied by x to the power of r, can't I? Of course, we're interested in x to the power of 7. In other words, when this power on the x is equal to 7, that's what we are interested in. The coefficient of that term is 10c7 multiplied by -12 to the power of 7. That goes to your calculator. Minus 15 on 16 is your coefficient. 11c, I. Okay, first part. 20c12 for the number of ways of selecting the black chefs, and 12c10 for the number of ways of selecting the white chefs. Multiply the two, then that's the total number of ways of selecting both the black and the white chefs, which goes into the calculator. The answer is then 8,314,020. For the second part, 12c4 for selecting for the different ways of selecting 4 out of the 12 black chefs to go into your first group. Here we'll have 3 groups altogether, 3 groups of 4. So 12c4 for the first group. You then, for the second group, would have 8 to pick from, 8 chefs to pick from which you select 4. Okay? And those 4 selected would make the second group. Now the remaining 4 unselected would naturally form the third group, wouldn't it? You could represent that with the 4c4, but that's actually meaningless because 4c4 is just equal to 1. Now, we must divide this by 3 factorial. Why? Why? Because in the selection process that we have just conducted, we chose 4 chefs for the first group, call it group A, and then 4 chefs for the second group, call it group B, and then the remaining 4 formed group C, didn't we? However, from the question, we should note that technically the 3 groups are should not be distinct from one another. As in our selection process, we treated them as group A, group B, group C, but technically there should not be group A, group B, group C. Okay, or speaking more from perms and coms kind of viewpoint, I could say. Okay. Let's suppose that 4 particular people out of the 12 black chefs, let's say that there are 4 particular people, A, B, C, and D. What this selection process, the 12c4 multiplied by 8c4, what we did there is we counted the case where these 4 particular black chefs, A, B, C, D, we counted the case where A, B, C, D go into group A, as being a separate case to the same particular 4 people, A, B, C, D, going into group B. And similarly, we treated that as a separate case, a distinct case from these 4 particular people, A, B, C, D, going into group C. However, I'm saying that should not be the case. As in, the cases where A, B, C, D go into group A, group B, and group C, right? What this calculation, right, treat it as distinct. Okay, what you know, that selection, the 12C4 times HC, what that 12C4 times HC4, what that counted as 3 separate cases should actually be one single identical case, is what I'm trying to say. Okay, so therefore we divide by 3 factorial because 3 factorial represents number of ways of arranging the 3 groups, or you could call it 3 factorial since we got 3 groups essentially. Put that in the calculator. $5,775 is the new answer. Next, vector projection of u1 to v is given by the formula u dot v over magnitude of v squared times v. And apparently that's equal to 5 and negative 12. But we can all see that the 5 on negative 12 is equal to negative, can't we? As in, these two are negatives of each other. And on the left hand side, u dot v, that is the dot product x1 times x2, so therefore a times negative 5 plus y1 times y2, so 12 times a minus 3 over magnitude of v squared, that's 5 squared plus 12 squared. This multiplied by v is the left hand side. And if we compare the coefficients of v, vector v, on both sides of the equation, we get that this then should equal to minus 1. Which if we rearrange to find the value of a, again, I'll skip the algebra, okay? You do the calculator work essentially. You get negative 19 as your answer. Next, 11e. Values of k for which the equation has a double root. Okay, multiple root theorem. The multiple root theorem states that the value of x for which p of x and p dash of x is equal to 0 is your double root. Again, I repeat, multiple root theorem, the value of x for which both your polynomial and its derivative is equal to 0 is your double root. Okay? So, let's consider p dash x. 3x squared minus 18x plus 15. 3 is a factor. Factorize the quadratic. And what can we see? P dash x is equal to 0 if x is equal to 1 or 5 is what we can see, isn't it? And again, multiple root theorem what? Multiple root theorem, double root occurs at the value of x for which px and p dash x is equal to 0. And what did we just find? We just found that p dash x is equal to 0 at x equals to 1 or 5. So then, k chosen so that the equation p of x equals to k has a double root, okay? Is then p of 1 or of 5, okay? Graphically speaking, this is the idea. The graph of the cubic polynomial px with the positive leading coefficient looks something like this. It looks something like that, okay? And then what we just found is that the derivative p dash x is equal to 0 at x equals to 1 and at x equals to 5. So they of course become the maximum and the minimum turning points respectively for your cubic function, right? And this equation on the graph which I drew is represented as the intersection of the horizontal line y equals to k, right? And the the graph of the cubic polynomial y equals to px, isn't it, right? And of course, if k is at the value that I have drawn, if k is right there where I've drawn it, the equation px equals to k would then have 3 distinct solutions, none of which would be a double root, right? But if we choose k to be either up here or down here, then at x equals to 1 and 5 respectively, x equals to 1 and 5 become double roots of the equation px is equal to k. So then what are the values of k that's required for this to happen? Well, in each case, the k would need to equal to the y coordinates of the stationary points over here, wouldn't it? That's why k is equal to p of 1 or p of 5. And of course, p of 1 or p of 5, you just chuck it into the equation of p of x to find them. And this is either then 7 or negative 25 is your solution, okay? Second part, show that the equation cannot have a triple root. Okay, again, then according to the multiple root theorem, if the equation has a triple root, then that triple root occurs at the value of x for which px, p dash x, and p double dash x is equal to 0. Multiple root theorem, okay? So for triple root, at triple root, double dash x is equal to 0. But what is p double dash x? Differentiate p dash. We get 6x minus 18. At what value of x is p double dash equal to 0? At x equals to 3. But at x equals to 3, is p dash equal to 0? And the answer is no. P dash, we already found, is equal to 0 at either x equals to 1 or x equals to 5, but not at x equals to 3. And according to the multiple root theorem, once again, if the equation was to have a triple root, then either one of these, 1 or 5, would need to make p double dash equal to 0 as well, but it doesn't. So therefore, the equation doesn't have a triple root. Okay? So, oops, p dash 3 is not equal to 0. So therefore, and then you write your conclusion that the equation px equals to k cannot have a triple root. Okay? Moving on. Integrating. Right. This you have to recognize that when you factor the x out from the denominator, like this, because x to the power of 3 on 2 is x times square root of x. But when you factor the square root of x out like that, and you split your square root, like this, you actually get the integrand in a form that you can integrate through the reverse chain rule. And recognizing that was the key to this problem. As in, in the index form, I can write my integrand as I have just done, okay? And I am saying that 1 over square root of x can be treated as the derivative of square root of x plus 3. I know it isn't quite, it isn't exactly the derivative. The derivative of the inside function, we call it the derivative of square root of x plus 3 in this case. I know that's 1 over 2 square root of x, okay? But, you know, it's a constant multiple of the derivative is what I'm saying. So we can apply reverse chain rule to do the integration. Because I'm saying the integrand is in this form. F dash x multiplied by your f of x raised to the power of negative half, isn't it? Okay? So what we would get is square root of 3 to the power of positive half, because the power goes up by 1 when you do the integration and apply the reverse chain rule. And you need to multiply it by 4 to compensate for your constants. This then produces 12 times this. And do not forget your constants plus c when you find indefinite integrals. Okay. Next. Kimono rental service. On average, 5% of the kimonos are damaged when they are returned to Mr. No. On a particular day, 70 customers. This will be your sample size n for the question. Probability that at most 5 of the 70 are damaged. 5 out of 70. But at most, P hat, the proportion of the kimonos which are returned and found to be damaged, okay, that proportion, right, out of 70, at most 5 on 70. Less than or equal to 5 on 70. Okay? And the question wants you guys to consider the probability of this occurring. Okay? Which, if you're gonna use normal approximation, would be approximately equal to the probability that your standard normal variable z is less than or equal to the z-score of 5 on 70. Now, what is the z-score of 5 on 70? Well, for us to figure out the z-score of 5 on 70, we then need to know the expected value, that's the mean, and the standard deviation of my sample proportion. Okay? We need to know the mean, the average, and the standard deviation of the proportion of the kimonos which are damaged. And the expected proportion of kimonos which are damaged is, of course, just as the question says, the on average 5%. And the variance is obtained through P times 1 minus P over the sample size n, isn't it? And your standard deviation is the square root of this number, square root of the variance, which you can write as 19 over 28,000. Okay? And once you know the variance, once you know the standard deviation to be the square root of that, and the expected value, the mean, again, the z-score of 5 on 70 is 5 on 70 minus the mean value divided by the standard deviation. That, in your calculator, indeed gives the 0.82, which the question wanted you to obtain. Okay? So that's the first part. Now the second part, will this estimation be greater than or less than actual probability? So it's a question here, this is a question that's testing your understanding of the fact that the proportion of damaged kimonos actually have a binomial distribution, which is a discrete distribution, and the fact that you are approximating that distribution with a normal distribution that is a continuous distribution. So in other words, if you consider the actual distribution of probabilities, well, you got p hat down here, and you got the actual probabilities. of each p hat value. That should start from 0 on 70, which represents the case when the kimonos are returned but none of them are damaged. So in other words, good news for Mr. No. Next value would then be 1 over 70, which represents again the case when 1 out of the 70 kimonos returned are damaged, okay, and so on. You have your 5 on 70 over here. Like this. But the actual distribution, as I've just drawn, okay, using a column graph essentially, is a discrete distribution because the proportion of the damaged kimonos can be 1 out of 7, it can be 2 out of 70, it can be 3 out of 70, but it can't be any value in between those discrete values, okay? As in, you can have 1 on 70 and you can have 2 on 70 as possible values of p hat, but you cannot have 1.5 out of 70. Right? Hence a discrete distribution. But what do you do? But you approximate that with a normal distribution that should have, this kind of shape, shouldn't it? That kind of shape, right? And the problem with doing that, okay? And the problem with doing that is, so yeah, with a normal curve that's got this kind of shape, and what do? You use the area under that normal curve to approximate the binomial probability, don't you? Right? Specifically, what we have done in this approximation in part I is that we noted that the proportion of 5 on 70 has got a corresponding z-score of 0.82. Okay, and then we used area to the left of 0.82. That is, we've used this area to approximate the sum of these columns, added, haven't we? However, the actual probability then, okay, which should include this entire column, right? But this extra area over here, which is not considered in the approximation, right? This extra half a column essentially over here, that's included in the actual probability, but it's not in the approximation, which is what then makes the approximation less than the actual probability. So the answer to the second part, estimation is less than the actual probability. Okay. Question 12C. A lot of students, I figured, had an issue understanding the wording of the question, but it's not that, I don't, it's complicated of, your question of says you're tossing 6 coins. So just imagine you're tossing 6 coins, and at the same time you're rolling a die. And what you need is you want the number of heads from the coins to be greater than the number rolled on the die. Okay? Which can occur, right? Which can occur. So on the die, you can either roll 1, 2, 3, 4, 5, or 6, right? And you're tossing 6 coins. So if your die shows 1, okay, then you can have 2, 3, 4, 5, or 6 of your coins showing heads, and then the number of heads that you obtain from tossing the coins is greater than the number rolled on the die, isn't it? So basically the number of heads that showed up from the 6 coins to be greater than the number that's rolled on the die, and that's exactly just what the question says. Okay? So if the number rolled on the die is a 2, then you need minimum of 3. So therefore, also 4, 5, or 6 heads out of the 6 coins. And you get the idea. Like this. Okay? And of course, guys, if you roll a 6 on your die, then the number of heads that you obtain from the coins can't be bigger than that. It can't be greater than that. Okay, so now what have I just summarized? What have I just summarized? I have just summarized all the cases for you, essentially, haven't I? All the cases for you. So you calculate the probability of each of these cases, and then you add all of them to find your total probability. So let's consider the first case. The first case, you roll a 1 on your die, okay? And when I consider the first case, let x be the number of heads obtained from tossing your coins. Okay? So the first case where the number rolled on the die is 1, right? Chance of that occurring, first of all, is 1 on 6, isn't it? Chance of the die landing on 1, that is 1 on 6. And when this occurs, you can either get 2 out of your 6 coins to be heads, the probability of which I can represent it as P of x equals to 2, or you can have 3 out of your 6 coins landing on heads, or you can have 4 coins, 5 coins, or 6 coins all landing on heads, can't you? Okay? In the second case, where the die shows a 2, again, the chance of the die showing a 2, that's 1 on 6 to begin. But this time, your coin can, 3 of your 6 coins can land on heads, or 4 of them, or 5, or 6. All 6 of them can land on heads, right? And so on, repeat it, until your last case over here. This is the case when die shows 5, isn't it? Case 5. Again, the chance of your die showing a 5, that again is 1 on 6. But when this occurs, you must get 6 heads out of 6 coins from your coin toss. So the probability that x equals to 6. And the total probability that the number of heads obtained from toss coins is greater than the number rolled on the uppermost face of the die. Okay, that's all of these added, isn't it? The total of which you're going to have 1 on 6 as your common factor. Okay, and then you can see that when you add these, you'll actually end up with a bunch of like terms. As in, you'll have 2 times p of x equals to 3, which you can see right here, here, and here, right? You'll have 3 times p of x equals to 4, 4 times p of x is equal to 5, and lastly 5 times p of x equals to 6. Okay, and that's because p of x equals to 6 appears here, here, and in other words in all 5 cases, doesn't it? Right? And each of these binomial probabilities, the probability that x equals to 2, that's the what? That's the probability that 2 out of the 6 coins that you tossed land on heads, isn't it? Okay, which according to the binomial probability, which is a binomial probability of 6c2 half to the power of 6. Choosing 2 out of the 6 coins to land on heads. The others would, of course, the other 4 would, of course, be tails. But the chance of a coin landing on head and tail are both half. They're the same. Okay, so 6c2 half to the power of 6. Similarly, chance of 3 out of your 6 coins landing on heads is 6c3 times half to the power of 6, and so on, and so on. Like that. Ugh. And you put that inside your calculator. Okay. And the answer that you get through this is 43 over 128. Okay. Right. Then to the next question we go. Okay. For this one, we'd have to begin by finding the equation of this tangent. And we all know the process of finding the equation of a tangent. So obtain the derivative of the curve first. Derivative of ln x is 1 over x. And the tangent at x equals to a can then be said to have a gradient of 1 over a, can't it? And the y-coordinate of this point which lies on the curve y equals to l, we can represent that as log base e of a. So the tangent is a straight line which passes through the point A, ln A with a gradient of 1 over A, isn't it? Okay, so the equation of the tangent would then be, I have just written down. But what do we know about this tangent? Passes through the origin. So what? Substitute 0, 0. And that should satisfy, shouldn't it? So in other words, negative ln A is equal to minus 1. That means ln A is 1 and A is equal to E is what we get. Such that what? Such that the equation of the tangent can then be expressed as log y minus log base E of this value of A is what we have just found. It's E. Okay. Like this? No, in fact, we don't even need to do that. We don't even need to do that, right? We don't even need to do that, okay? Since we know the tangent passes through the origin, its equation is just going to be y equals to mx, y equals to m times x, where m is the gradient of the tangent, isn't it? And the gradient of the tangent we just figured out to be 1 over e is tangent equation. All right. Which, if you rearrange to make x the subject, x is e times y. Similarly, if you rearrange the curve equation to make x the subject, x is e to the power of y. Now, why do I make x the subject? Because now we're going to find the volume. When the shaded area is rotated around the y-axis, then the volume should be pi times the integral taken from 0, and what we just found is that this y-coordinate is 1 because this a value is e. So the integral from 0 up to 1 of the upper curve e to the y squared minus the under curve e times y squared dy. And if you evaluate that integral, you then can find the volume of the solid that is formed, okay? Which is not difficult integration at all. There you go. Upper minus under. Simplification. And that unit cubed is the volume that's formed. Okay? Now, the last question of question 12, mathematical induction. So let's quickly establish the base case. When n is equal to 1, your left-hand side is the first term over here, isn't it? 5 over 1 times 2 times 3, which is 5 on 6. Your right-hand side, 1 minus 1 over 2 times 3, which is also 5 on 6. Therefore, the base case established. Assume the statement true for n equals to k. Which involves us rewriting the given statement but just replace every n with a k, so that last term of the sequence on the left hand side, 2k plus 3 over k times k plus 1 times 3 to the power of k. On the right hand side, 1 minus 1 over k plus 1 times 3 to the k. That's what we've got to do. And then for n equals to k plus 1, what we are required to prove we are required then to prove using the assumption that all of that on the left hand side plus one more term. Plus one term when n is equal to k plus 1. So on your numerator, you would have 2k plus 5. On the denominator, you would have k plus 1 times k plus 2. Multiplied by 3 to the power of k plus 1. We are required to show that this is equal to 1 minus 1 over k plus 2 multiplied by 3 to the power of k plus 1. Okay? And then actually now performing the inductive step of showing that, okay, which I will do up here, guys, right? Left hand side, here is the assumption, see, up to here, all of this is the assumption, isn't it? Which is equal to this. Assumption plus one extra term at the end over here. Okay, and this is from our assumption. Okay, which can then be simplified to, we can put these. We can find that the lowest common denominator of those two fractions is k plus 1, k plus 2, 3 to the power of k plus 1, and we can put them together in a single fraction. But in order for us to do that, the term of this would need to be multiplied by k plus 2 and the 3. Okay. And the second term, the 2k plus 5 on the numerator, that doesn't have to be multiplied by anything, right? Just be careful that the positive turns into a negative, okay, when you combine the two fractions because of the negative LTR, okay? Then what do I have? Then on that numerator, if I expand and collect like terms, I end up with k plus 1, which of course cancels the k plus 1 on the denominator, and I end up with the right-hand side of my required to prove. Oops. As required. Okay? Of course, guys, for your induction, after this inductive step, you then just write conclusion saying that therefore by principle of mathematical induction, blah, 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 the statement is true. All integers n greater than or equal to 1, and then you end your proof like that, okay? Yes. All right, let's start question 13, vectors question. OABC is a parallelogram, and you got a center circle that X that passes through O. And the the circle intersects with OA, OB, OC at points P, Q, R as shown in the diagram. Let M be the midpoint of OR and OQ be equal to KB, OQ, equal to K times OB, where K is greater than 0. First part is to use the fact that OC and XM are perpendicular. So if you look over here, if you draw XM and you note the fact that this is perpendicular to OC as the question says, that is essentially telling you that then XM, this, is the perpendicular bisector of OR, isn't it? Right? Because M is also the midpoint of OR. Now, in the vector form, that can then be expressed as XM is half of XR plus XO. Right? To again denote the fact that XM is the perpendicular bisector of OR. And also, since OC and XM are perpendicular to each other, XM dot OC should be equal to 0. So, you can then say half times XR plus XO dot OC is equal to 0. And you can work with that until you essentially derive the expression that the question wants you guys to derive. Okay? And for that, you can see that, then I probably want to keep my XO and OC because that's also in the expression OC, OX, OC that I need to derive. But I should change XR because the expression that I need to derive doesn't contain XR. So have a look at XR. The vector xr is the vector or minus the vector ox, isn't it? And of course, the vector plus the vector xo can be written as negative of ox. Which becomes that. And if you expand it out, you get that, which if you make or.oc the subject, you get the expression that is required by the question in part I. Okay? And then guys, for the second part of the question, by deducing a similar result for op.oa and oq.ob. So what we have just shown in part I is that the vector or over here, or, right, dot oc over here, okay, is equal to 2 times ox.oc. So then when they say, deducing similar results for op.oa and oq.ob, what they're talking about is op.oa, okay, which is the other side of the parallelogram over here, is 2 times ox.oa, because logic is, you can see that going from the first part to the second part, okay, essentially the OR is replaced by OP and the OC is replaced by OA, isn't it? So on the right hand side, OC should be replaced by OA. And similarly for OQ.OB, you should be able to say that's equal to 2 times OX multiplied by OB. Right? Now noting those results, the sum of the two of them, those two added, OP.OA plus OQ.OB, OP.OA plus, actually, OR.OC, which you guys got in part I, should then be equal to 2 times OX.OA plus 2 times OX.OC, which is 2 times OX dot OA plus OC. And OA plus OC, if you look in your parallelogram, OA plus OC, that's the diagonal OB in your parallelogram, isn't it? So 2 times OX dot OB, which we deduced is equal to OQ dot OB. And that is the end of that question. Now, 13b, logistic question, typical logistic question, which we should solve by separation of variables and then the integration. So Separate out your variables first, meaning move the p's over to the other side, and then we get $12,000 over p times 12,000 minus p, dp dt is equal to r. Now use the given fact on the left hand side. There we go. And integrate both sides with respect to t. Like this. So you end up with an integral in terms of p on the left hand side, integral in terms of t on the right hand side, which if you perform the integration, you're able to find the relationship between p and t. Apply the log laws as usual. There we go. Continue with the calculation. Take the exponent of both sides. Remove the absolute values, which would require you guys to write plus or minus, and e to the power of c, or plus or minus e to the power of c, can be generalized a. This is your arbitrary constant. And the value of can be found by substituting in the initial population that the question describes. The question describes the initial population, the population at the year 1990. It describes it to be 4,000, doesn't it? Which means at t equals 0, population is 4,000. Substituting that in changes e to the power of rt to e to the power of 0, so therefore 1, and that gives you the value of a. When you sub 4,000 into the other side, 4,000 over 8,000 is half. And also you can find the value of r by subbing in the fact that the population is 9,000 in the year 2004, which of course is 24 years after 1990. So when at t is equal to 24, population is equal to 9,000. From which you get, now we know a is equal to half e to the power of 24r, equal to sub 9,000 onto the side. 9,000 over 3,000 gives you 3. So rearrange that. To find your value of r, and there we go. Okay? Now we know all our constants. We know the arbitrary constant a, and we know the growth rate constant r. Rearrange this now to make p the subject, your population the subject, because our job in the question is to estimate the population in the year 2024. Now 2024 is 34 years after 1990. So our job is to estimate the population P when time t is equal to 34, isn't it? To do that, like I said, rearrange this to make P the subject. So what I'm going to do is I'm going to flip both first. So I obtain that, which then means 12,000 on P minus 1, which I can move over to the other side, is equal to that. And flip both sides once again. There we go. So therefore, your population, and in the year 2024, at t equals 34, population is then 12,000 over 1 plus, now a was half, so 1 over a is 2. And we found the growth rate constant R to be ln 6 on 24. So 2 times e to the power of negative of that. ln 6 on 24 multiplied by your time, 34. Okay. This goes into the calculator, and which approximates the population to be around 1,363 to the nearest number of tuners. Okay. Projectile. So, what the question is describing essentially is when the particle, okay, is at the point shown on the Cartesian plane. Okay, let's suppose that point has got the coordinates x and y. Essentially, of course, the position vector of the projectile given, they're giving us that x and y coordinate respectively, okay? And the angle theta is the angle inside this triangle, this right angled triangle, okay? Where the opposite side of theta is of course equal to y, and the adjacent side of theta is equal to x, isn't it? This right angle triangle. Okay? Such that tan theta can then be expressed as y over x, which is that, and that simplifies to tan alpha minus 5t squared over, in fact, one of the t's cancels, so 5t over v cos alpha. Okay. That's the relationship describing theta. That's the relationship describing essentially what theta is. Okay, if theta is the angle of elevation from the origin to the particle, Now for phi, the other angle, which is the angle that the velocity vector makes, I first need to find the velocity vector, which of course is just the derivative of the displacement vector with respect to time. And that's v cos alpha, v sine alpha minus tan t, isn't it? And again, guys, this is your y dot and x dot, the other way around. The other way around, actually. This is the components of your velocity vector, that is always your x dot and y dot respectively. And phi, guys, they're saying at any time t, angle phi is essentially, if you have your velocity vector like this, angle phi is the angle inside the right-angled triangle where the side opposite phi represents the vertical component of the velocity, so y dot, and the angle adjacent to phi, the side adjacent to phi, angle phi, represents the horizontal component of the velocity x dot, such that tan phi is y dot over x dot, which we can write as this. And again, if you simplify, well, not really simplify, but if you divide v sine by v cosine, you get the tan alpha after the v's cancel, and you get that expression. So what do we have over here? We've got tan theta equal to this, tan phi equal to this. And our job in the first part of the question is to deduce this relationship between theta, alpha, and phi, okay? Which then allows us to think, right, that I should probably then eliminate this term that contains t, okay? By solving the two equations that I have, 1 and 2, by solving them simultaneously, I should eliminate that term that contains t. And then when I do that, I should be able to obtain the relationship between theta, phi, and alpha, right? Right? So, if you look at equation number 2, equation number 2 can be written as tan phi being equal to tan alpha minus 2 times this. Into which, of course, you can substitute in equation number 1. Because according to equation number 1, 5t over v cos should be tan alpha minus tan theta. And then if you rearrange what you get, you end up with what the question wanted us to obtain. 2 tan theta is equal to tan alpha plus tan phi. And then the second question, second part over here. Let S be the point on the particle's trajectory where theta is alpha on 2 and t is the point on the, what that means is that S, the point S, right, is some point on the particle's trajectory. In other words, guys, it's somewhere on this thing, on this parabola, where theta is equal to alpha on 2. So in other words, it'll probably be somewhere around here, point S that is, such that angle theta over here, right, is half of the launch angle alpha. Okay, and likewise, point T is just somewhere on the trajectory, right? Point T could be after point S or it could be before point S. We don't know, but point T is also somewhere on the trajectory. And at point T, angle phi is equal to negative alpha on 2. And your job in the question is to show that particle reaches S before it reaches T if alpha, the launch angle, is less than pi on 3. And listen carefully to how I interpret reaching S before it reaches T. Okay? To me, that's an indication that time taken to S is less than time taken to T. So what I'm going to do is I'm going to begin by finding the time taken to reach point S and reach point T respectively. Now the first one, the time taken to reach point S, comes from equation number 1. This that I have. Let me copy that and use that in part 2. Okay, from equation number 1, guys, at point S, we know that this angle theta is equal to alpha on 2. So I can rewrite that as alpha on 2. And then if I rearrange this to make theta subject, like this. This should then be the expression for the time taken to reach point S, and that I will denote it as TS. Okay. Similarly, guys, I can use equation number 2 that I have over here. So again, I'll just copy that and use that to calculate the time that it takes to reach point T. So again, I will just borrow this and use the fact that at point T, this phi is equal to negative alpha on 2. So I will rewrite this as negative alpha on 2. And that equation is arranged so that the T over here becomes the subject like this. Is then what? This is then the expression for the projectile to reach point T, and I'll denote that T of capital T. Okay? And what we need to show in the question is if alpha is less than pi on 3, okay, we then need to show that this expression is less than this expression. Okay? Sorry, this one less than this one if alpha is less than pi on 3. That's what we essentially have to show. And in order for me to do that effectively, what I'm going to do is I'm going to find an expression for the difference between the two times. Ts minus Tt, okay? Which is just subtracting these two from this one. Subtracting the other one over here. And I'll skip the algebra a little bit. But if you take the difference, you end up with V cos alpha times this as your fraction. Okay? And I skipped the algebra because I believe all of you guys can handle the algebra on your own, right? But more importantly, why do I consider the difference between the two times? Why do I consider the time difference, guys? It is because, again, if, as the question requires, if Ts is less than Tt, okay, then that time difference, Ts minus Tt, will be negative, wouldn't it? Okay, so if I can show that Ts minus Tt is negative, I've done what the question has asked me to do, right? And for me to do that again, what I'm going to do is I'm going to consider when the time difference is 0. In other words, when the particle reaches point S and point T simultaneously at the same time. Then for the time difference to be 0, because V can't be 0, and similarly cosine alpha is only 0 when the launch angle alpha is 90 degrees, but here the launch angle is not 90 degrees. The launch angle will be an acute angle between 0 and 90. So for those values of alpha, cosine alpha can't be 0 as well. Of course, that then means that the last remaining factor tan alpha minus 3 tan alpha on 2. This must be equal to 0. Okay? And solving this equation will allow me to find the launch angle alpha, which makes the particle reach points S and T simultaneously, which makes the time difference Ts minus Tt equal to 0. So let's do that. Trig equation, solving. I've got to begin by matching my angles. Alpha on 2. Alpha is double alpha on 2. Double angle formula. There we go. Now I'll put everything over 1 minus tan squared alpha on 2. And again, I'll skip the algebra a little bit because all of you guys can do the addition and the factorization yourself. You end up with that. Okay, when you put the two terms together, which of course then means for this to be equal to 0, it then means either tan alpha on 2 is equal to 0 or tan alpha on 2 is equal to plus or minus 1/3. Okay, but again keep in mind that alpha here is between 0 and pi. So 2 would have between 0 and pi on 4. Okay, And in that interval between 0 and pi on 4, the only equation out of these that actually has a solution is tan alpha on 2 equal to positive 1 over root 3. The negative one does not have a solution in this interval. And that solution is at alpha equal to pi on 3, right? And you can see that you are getting closer to what you need to get, because what have you just shown? You've just shown when alpha is pi on 3. In other words, when the launch angle is 60 degrees, you have shown that the particle, the projectile, reaches points S and T on its trajectory simultaneously, such that the time difference, the time it takes to reach S minus the time it takes to reach point T is equal to 0, okay? And all we now need to consider is, what if alpha is less than this then? Okay? What if alpha is less than this, right? If alpha is less than pi on 3. So for example, alpha is equal to pi on 4, because pi on 4 is a value that's less than 6. Then guys, Ts minus Tt, this expression, you sub alpha equals to pi on 4 into that expression. Into the calculator, you end up finding that this is roughly equal to negative 0.017 v. And again, v, the launch speed being positive, means the time difference is negative, less than 0. Okay? So what have you just shown altogether? Summarizing what you have shown altogether, what you have shown is, guys, that if I graph the against different launch angles alpha, I've shown that the time difference has a 0 at pi on 3. Ts minus Tt is a continuous function. And I've shown that pi on 3 is the only 0. Okay? Only 0, guys. It's the only 0 of a continuous function in this interval. So in other words, from 0 to pi on 2, in that interval, pi on 3 is the only 0 of a continuous function, and I've shown that when alpha is less than pi on 3, so for instance, when alpha is equal to pi on 4, I've shown that the time difference takes a negative value, is what I've shown. Okay? But because, again, this is a continuous function in the interval of alpha between 0 and 90, okay, that has got its only 0 at pi on 3, then if alpha is less than pi on 3, no matter what the graph looks like, we don't exactly know what the graph looks like, and we don't care what the graph looks like for this function. We don't care what it looks like. It could look like what I have just drawn, right? Or it could look like, that. I don't care what it looks like, right? But what I know is that for all values of alpha less than pi on 3, Ts minus Tt is negative. That's what I know, right? Such that what? Ts is then less than Tt. Ts is less than T2, meaning what? Particle reaches point S before it reaches point T if alpha is less than pi on 3. Okay? Now, question 14. Find the equation of the inverse function and state its domain. Right. Well, I'm going to find the inverse function by starting with y equal to f of x like this. I'm going to find the inverse function by making x the subject and then interchanging x and y. Okay, but before I do so, guys, okay, one other thing which I'm going to consider is I'm going to consider the value of f of negative ln 2. Okay, and for now, why all of a sudden negative? It doesn't have to be, guys, negative ln 2, right? It doesn't have to be it. What I did is I just randomly chose a value of x that's less than or equal to 0. Or preferably less than 0. That's what I've chosen. Okay? So you guys could have chosen other negative x values is what I'm saying, right? There's no, clear logic or reason behind negative ln 2. It's just a random negative value. Okay? And the value of f of negative ln 2 is this, which simplifies down to 5 on 4. If you do the calculations, again, I skipped the arithmetic. If you do the calculations, it reduces down 5 on 4. Okay, so I guess there was a little logic, right, idea behind why I made x a log value. Okay, that's because I wanted e to the power of log to cancel each other out, right, and give me a clean value, right? So I guess that was that logic. But more importantly, this means your function passes through negative ln 2, 5 on 4. And I'm going to use this quite effectively later on. Okay? So back to finding the equation of the inverse function. Make x the subject. So multiply both sides by 2. Move everything over. To one side of the equation. Multiply both sides of the equation by power of x. Why? Because this is actually a quadratic in e to the power of x. So to make x the subject, we can actually use the quadratic formula to find an expression for e to the power of x. And that'll be minus b plus or minus b squared minus 4ac all over 2 times a, which if you do some simplification, and sorry, this was meant to be a minus here, wasn't it? So no minus in the quadratic formula. And if you do the simplification, you get this. So what? X is equal to ln of that thing. Okay? And of course, guys, your equation of the inverse function is then stated by changing x and y, okay, in that equation. But here is where I am going to use this thing quite effectively, because now then for me to state what the equation of guys, the inverse function is, and also I need to find its domain, don't I? But in order for me to do that, I need to pick, guys, between the plus or the minus, okay? For my inverse function, I need to pick between plus or minus over here, okay? Which can be done through the fact that since my function passes through negative ln 2, 5 on 4, my inverse function should pass through 5 on 4, negative ln 2, shouldn't it? Right? That, okay? That idea, right? So that is when you substitute in 5 on 4 into the y over here, your x should be negative ln 2 for your inverse function. Okay? And you chuck in 5 pi on 4, right? You test the plus or the minus. You test plus or the minus, right? To figure out which one makes your output equal to negative ln 2. Okay? And when you do that in the calculator, you can realize that it is the negative 1. Right? Since f inverse of 5 on 4 needs to be negative ln 2, right? And of course, I did say for the equation of the inverse function, I was going to replace y with x, okay? But when that x is equal to 5 on 4, you must get negative ln 2 as your output function value, and that's only possible if the operator in the middle over here is a minus, not a plus, okay? So using that point that your function and correspondingly your inverse function passes through, you can determine whether this should be positive or negative, okay? And then the domain of it, right? Domain of it, okay? Well, usually the domain of an inverse function, you can find it through the range of the original function, right? However, since we got the equation of the inverse function over here, okay, this time, we can also note the fact that we have x squared minus 1 under a square root, okay? So that x squared minus 1 would need to be greater or equal to 0, which then means that x is greater than or equal to 1, or x is less than or equal to minus 1. Okay? One or the other, but if x is less than or equal to negative 1, inside our ln, we have a negative number subtracted by another number. We got a negative number subtracted by a positive number actually, because square roots are positive numbers. Negative number subtract a positive number, then the whole expression will become negative, wouldn't it? But if an expression inside ln is negative, then my inverse function is undefined. So x can't be less than negative 1. X must be greater than or equal to 1. And that is the domain, actually, of this function. This one. Okay? When you sub in values of x which are greater than or equal to 1, right? You will realize that this expression it no longer is negative, it gives you positive values. Okay? Which then means your inverse function is defined for those values of x. Okay? So that's the equation of the inverse function and the domain. Done. Moving on. Okay, sketching. The graph of f of x is of course a concave down parabola that's got roots at a and b, but both a and b are positive numbers. So your parabola would then look something like what I am sketching right now. Right now, like that. And it's set to label all the intercepts. So this would be A, this would be B, and the y-intercept at x equals to 0, this would be negative AB. If you substitute x, if you find f of 0, essentially. Okay, and that's the graph of f of x. Okay, and the significance of them telling you f of a plus b on 2. Now, what's a plus b on 2? A plus b on 2 is the midpoint of the two roots. And of course, for a parabola, the midpoint of the two roots is where your vertex occurs. Okay? And them telling you that the function value at the vertex is bigger than 1 is just telling you that the y-coordinate of the vertex is bigger than 1. Okay? It just means you have 1 somewhere below the vertex, right? That's the graph of f of x. And we also have to sketch the graph of the square root reciprocal. So, what I'm going to do is I'm going to have vertical asymptotes at x equals to a and x equals to b respectively, because at the zeros for this function, at the zeros, 1 over square root of 0 is 1 over 0, so that's undefined, isn't it? Okay? And then next, on this side, and on this side, right? Whereas we can see f of x values, the function values are negative, right? I'm not going to have a graph, okay? Because if f of x is negative, square root of f of x, which I have on the denominator over here, that's so my function, my transformed function is undefined for those values of x, right? Now, at the points at which f of x is equal to 1 then, these points that is, I'm going to have the points of intersection between my transformed graph and the parabola y is equal to f of x. That is again because at those points y is equal to 1 or f of x is equal to 1, okay? And 1 over square root of 1 is just 1 again, right? Based on all this, how does the transformed graph look like then? 1 over square root of f of x. Also, when you take the reciprocal of a number, small numbers become bigger large numbers become smaller, right? Or you can test it out yourself, right? You can test it out yourself, okay, to recognize that here, around this value, right, you know, my f of x is around half, right? Then what, for my transformed graph, what is 1 over square root of half? Oh, it's the square root of 2. Okay, vice versa, right? Here, okay, my f of x value is 2. So for my transformed graph, what is 1 over square root of 2? It's 0.707. That's down here. Okay, so by testing a few points like that, you can then figure out that your transformed graph then should look, guys, as follows. Okay, and I will just put that one in a different color for you guys. And it's that transformed curve that follows these two asymptotes, isn't it? Okay. Now that's the sketch done. The next part, integration by substitution. So, to do integration by substitution, we usually begin by finding dx, don't we? By differentiating what we are substituting. So obtain the derivative of what we are substituting. Cosine squared and sine squared are differentiated using the chain rule, respectively. So 2a, cosine, lower the power by 1, and then multiply this by the derivative of cosine, which is negative sine, plus 2b, sine, lower the power by 1 once again, multiply by derivative of sine, which is cosine. Okay? Chain rule for the differentiation of dx, essentially. But you guys can see that the two terms now have got common factor of 2 sine t cos t. And of course, that common factor 2 sine t cos t, oops, 2 sine t cos t, according to the double angle formula, is sine 2t, isn't it? To t, right? And that's expression for dx. We also need to change these boundaries, a and b. So when x takes those values, let me do it up here. When x is a, it of course means, guys, a cosine squared t plus b sine squared t is equal to a. Now let's find what the value of t here is equal to. So if I move everything over to one side, I get the following equation. But you can note that, 1 minus cos squared, that's sine squared. So sine squared is a common factor. That I can factor out like this. Okay? And of course, this means either a minus b is equal to 0, but a minus b is not equal to 0 because a is not b. In the question, we were told that a is not equal to b, right? A is less than b. Okay? So a minus b can't be 0, so it's the sine t that must be 0, right? Now for sine t, for this to be equal to 0, well then t must be 0. Or t can be 0. Okay? And guys, similarly, if you do similar calculation for the other boundary, that's when x is equal to b, okay? You're able to obtain that t is equal to 90 degrees or pi on 2, right? And now we are ready to make the substitution. So b on a, 1 over square root of f of x dx is then pi on 2, 0, square root of f of that thing that we have substituted into x, isn't it? And the dx at the end changed into this. And the dt usually, you can write that at the end. So then what is the square root of f of a cosine? What is this thing? Well, from the question, we know the equation of f of x. We know the equation of f of x. Okay, so we can rewrite that denominator as this thing minus a, because our equation of f of x has x minus a, as you can see, x minus a, and then b minus x, so therefore b minus this, but of course that would change the plus to a negative. That is f of a cos squared t plus b sine squared t. Now, in our integrand, we have this under a square root. Don't we? And the numerator, for now, stays the same. Okay? And if you look now, the denominator looks extremely messy. Let's actually clean this up a little, okay? And cleaning this up a little, guys, once again, involves the same trick that you guys have used when you are changing the boundaries, right? As in a cosine squared minus a. You can factorize the a, and the resulting 1 minus cosine squared, you can change that to sine squared, okay? You can clean up the denominator as b sine squared t minus a sine squared t. Similarly, by factorizing b in b minus b sine squared, have b cos squared t minus a cos squared t. Same numerator dt. Okay? And then further factorization simplifies the denominator to b minus a sine squared multiplied by b minus a cosine squared. Such that what do we have under the square root now? We ended up having a perfect square under the square root. Didn't we? Numerator once again stayed the same. Such that we can remove the square root, because under the square root we have b minus a, we got two of them, b minus a squared. So take the square root of that, right? And then we get b minus a. Okay? Square root of b minus a squared becomes b minus a. Right? And here we know this because b is larger than a from the question. So b minus a is a positive number. Similar for the values of t, the angle t that's considered in the question, which are acute angles between 0 and pi on 2, we know that sine t and cosine t are positive ratios. So square root of sine squared is sine t, because sine t is a positive number. Right? Same for cosine. We get this. And then b minus a cancels. Sine 2t is 2 sine t cos t, which cancels the sine t and the cos t on the denominator as well. So you end up with 2 as your integrand. And that, of course, 2t upper pi on 2 under 0, you evaluate that, you get pi. And of course, pi, guys, is independent of a and b, as the question requires it to be, isn't it? Okay? So that's the integration by substitution. Now the last question over here. As you may have already noticed, I put quite an emphasis on trigonometric equations and trigonometric functions in this test paper. A lot of especially the questions towards the harder questions towards the end of the paper involve understandings of trigonometric functions and trigonometric equations. I did that because, well, basically I felt like it. Okay, as in I felt like that tomorrow's paper would have an emphasis on trigonometric equations. It was just my gut feeling. Okay. So, well, if it in fact does tomorrow, well then, good for you guys, okay? Good for you guys, right? The last question, question 14C, is also a trigonometric equations question. The first part, using compound angle formula, treating tan 3 theta as tan 2 theta plus theta, and applying the compound angle formula, gives you that. And to get down to the right-hand side of part I, we also need to apply the double angle formula to reduce 2 theta down to theta. And of course, your double angle formula is that And there you have it. Okay, we clean this up by multiplying top and bottom by 1 minus tan squared, 1 minus tan squared, which gives us two tan theta plus tan theta multiplied by 1 minus tan squared minus tan squared minus 2 tan squared theta. Okay. Which if you guys now just collect the like terms on the numerator and on the denominator, you end up with the expression which the question needed you to get. There we go. Okay. The second part of the question, a very easy question. So if theta is cosine inverse 2 on root 5, well, it then means, guys, that your theta, okay, is inside an it's an angle inside a triangle, because the given information means that cos theta is 2 on root 5, meaning in the triangle that I've drawn over here, the ratio of the hypotenuse, the adjacent side to the hypotenuse, is 2 on root 5, which means the opposite side is 1 by Pythagoras' theorem. Okay? And we also know that since theta is cos inverse 2 on root 5, okay, we also know from this given information that theta is an acute angle. It's somewhere between 0 and pi on 2. Why? Cosine theta is a positive ratio, right? And also, by definition, inverse cosine functions, right, or inverse cosine function values by definition are either acute or obtuse. Okay, cosine inverse functions have a range that is between 0 and pi, right? But here we're talking about value of theta, which makes cos theta a positive value. So that theta will be acute, between 0 and 90, which is why I put it inside a right angle triangle. Okay, and from the same triangle, tan theta is then a half, isn't it? Positive half. Again, why? Theta is acute. So by part I, tan 3 theta, if tan theta is half, then tan 3 theta, 3 times half minus half cubed all over 1 minus 3 times half squared. Put that in the calculator, you get 11 on 2 as required. Okay? And then for the last part of the question, hence or otherwise find the exact values of the solutions to the equation tan 3 cos inverse x equals to 11 on 2 for x between -1 and +1. Well, for that part, let me begin by letting alpha equal to cos inverse x, or actually theta equal to cos inverse x. So the equation that we have to solve this one can just be written as tan 3 theta equals to 11 on 2. Okay. 4. Now, of course, since we let theta be cos inverse x, the range of values that theta can take would have to be between 0 to pi. Okay? Tan 3 theta is equal to 11 on 2 is the equation that we have to solve, right? So what am I essentially doing? By making the equation tan 3 theta equals to 11 on 2, right? What I'm essentially doing is, what I'm saying that I'm going to do is from here, I'm probably going to then find the values of 3 theta, right, that satisfy, that make tan 3 theta equal to 11 on 2. And then I'll divide each of those values by 3 to find the values of theta. And once I know the values of theta, I will sub those values of theta back into what I have just underlined to then find the values of x. That's what I'm saying I'm going to do. Okay. And so from here down to theta, okay, and then down to x by subbing it back into, again, what I've just underlined, right? That's what I'm going to do. But in that process, guys, part two, the previous part, has already told us one of the solutions. And that solution is, of course, 2 over root 5. Why? Because x equals to 2 over root 5. 2 over root 5 is a value that lies inside -1 and 1. And if x is equal to 2 over root 5, here, if this x is equal to 2 over root 5, we know that tan 3 times cos inverse 2 over root 5 is indeed 11 on 2 from part 2. We've shown in part 2 that if x is 2 on root 5, then tan 3 cos inverse x, tan 3 cos inverse 2 on root 5 is indeed 11 on 2. That's what we've shown in part 2. So we've essentially shown that x is equal to 2 on root 5 is one of the solutions to this equation in part 2. Okay? But of course, if x is 2 on root 5, well then theta would be cos inverse of that, and 3 theta would be 3 times that, wouldn't it? Okay? And listen carefully to this idea. If then this is a value of 3 theta, okay, that makes tan 3 theta equals to 11 on 2, well then, so is pi plus that. Okay? The logic behind it is, again, quadrant properties. By quadrant properties, the logic behind it is that tan 3 theta tan pi plus 3 theta, and similarly tan 2 pi plus 3 theta, these are all equal to each other by symmetry, right? Or by the cyclic and the periodic nature of these trigonometric functions, okay? They're all equal. So in other words, right? If the tangent ratio of this value is equal to 11 on 2, well, the tan ratio of pi plus that will also be equal to 11 on 2. And of course, so will this. Okay? 2 pi plus, right? Essentially, what I've done, okay, is nothing different to solving just tan 3 theta is equal to 11 on 2. Right? You know, when you do that, you find your so-called related angle, or you find your, one of your solutions, right? And then for tangents, which are positive, right? You take the same angle in the third quadrant, which is pi plus that, right? As your another solution. And then you subtract 2 pi to the two solutions that you have to find the rest of the solutions that lie inside. Since theta is between 0 and pi, 3 theta would have to be between 0 and 3 pi, wouldn't it? And in that interval, I've just taken 3 values that satisfy the equation, 3 values of 3 theta, okay, that make tan 3 theta equal to 11 on 2. Right? Now, what's theta then? What are the corresponding values of theta? It's these. And now, how do I find, and after that, what we're going to do, we're then going to use this relationship to find the corresponding values of x now, won't we? What are x then? Well, x is essentially obtained by taking cosine of each of these theta values. Like this. Okay. And then in the solution I did is for these two solutions, that is, I've used the compound angle formula to find the exact values of these, okay, in its simplest form, right? And that I will skip in this video because the video is already getting quite long, right? I believe, I believe you guys can do that calculation yourself, okay? But yeah, the answers that you get by simplifying these expressions down using compound angle formula, okay? And of course, the 2 on root 5, those 3 values of x are the solutions to this equation, okay? Yeah,